Hi, this is Nesniewski. We're doing Discrete Structures, Section 4.4, Recursive Definitions. We're going to do these homework problems. As always, you should do the problems yourself first and then check your answers here. Okay, 7 and 9 I remember are difficult, but we'll work it together. Okay, we recursively divide S0, so this is number 1. S0 is equal to 1. Sn plus 1 is equal to 2 divided by Sn. Okay? List the first few items in the sequence. Okay, so let's do it. So S1 is S0 is equal to 1. S1 is equal to 2 over 1. Good. Which is equal to 2. S2 is equal to 1 over 2. No. I'm sorry. Is equal to 2 over 2. Okay, that's the previous one, which is equal to 1. S3 is equal to 2 over 1. That's the 1, which is equal to 2. S4 is equal to 2 over 2, which is equal to 1. Get the pattern, 1, 2, 1, 2, 1, 2, etc., etc. Okay? What is the set of values for S? 1 and 2. So that takes care of that. Okay. That was pretty easy. Number 2. We recursively defined SEQ, so this is 2, SEQ of 0 equals 0. SEQ of n plus 1 is equal to 1 divided by 1 plus SEQ of n. Okay. Calculate SQN for n equals 1, 2, 3, 4, 6. Okay, so let's do it. SEQ of 1 is equal to 1 over 1 plus sequence of 0, which is 0, so that's equal to 1. SEQ of 2 is equal to 1 over 1 plus 1, that's that, and that's equal to 1 over 2. SEQ of 3 is equal to 1 over 1 plus a half. What's that? 1 plus a half is 3 over 2. 1 plus a half is 3 over 2, so that's 2 over 3. 1 over 3 over 2 is 2 over 3. Okay, good. SEQ of 4 is equal to 1 over 1 plus 2 over 3. So this is equal to 1 over 3 over 3 plus 2 over 3. This is equal to 1 over 5 over 3, which is equal to 3 over 5. Let's do SEQ of 5 is equal to 1 over 1 plus 3 over 5. This is equal to 8 over 1 over 8 over 5, which is equal to 5 over 8. Okay, SEQ of 6 is equal to 1 over it's going to be 5 over 8, so I'm going to write this as 8 over 8. So this is going to be 1 over 13 over 5 over 8, which which is equal to 8 over 13. Okay, so we calculated a few. That's it. That's what they want us to calculate. That's it. They don't ask us to find any formula, but just you could see a little formula. This has a 1 on the bottom. This has a 2, 2, 3, 3, 5, 5, 8, 8. Looks like Fibonacci's numbers somehow are in there. But they didn't ask for anything, so let's just do that. Next, 3. Okay. Consider the sequence 1, 3, 9, 27, 81, dot, dot, dot. Okay? Give a formula for the nth term where sequence of, so SEQ of 0 is equal to 1, SEQ of n plus 1, just take each one as multiplied by n. So this becomes 3 times SEQ of n. 1 times 3 is 3, times 3 is 9, times 3 is 27, times 3 is 81. So that takes care of that. Okay, that's number 3. 3b, give a recursive definition. We give a recursive definition for this. So it's very simple. SEQ of n plus 1 is equal to 3 plus 1. That's it. Starts off as 0. I'm not sure I understand the question. The formula. Oh, I'm sorry. I messed up. So here's the recursive. So this is part C. This is part B. Good. Next. Number 4. We give you 2 sequences. Okay. 2 to the 2, 2 to the 2 squared, 2 to the 2 squared, squared. Okay, let's just do the numbers. This is 2, 4. This is 4 squared is 16. This is 16 squared is 256. Dot, dot, dot. So they want a recursive definition of this sequence. Very simple. So this is going to be f of 0 is equal to 2, and f of n plus 1 is equal to f of n squared. Just take the previous one and square it. Square it, square it, square it. Great. Next, that's part A. Part B, they want to show you the difference between A and B. So this is also starts with a 2. Whoops. Also starts with a 2, and then a 2 to the 2, and then it's 2 to the 2 to the 2. And then it's 2 to the 2 to the 2 to the 2. Etc., etc. So let's go through this. This is also starts off as 2. Also, it has a 4 over here. Okay, and here's 2 to the 2. That's a 4. 2 to the 4. 2 to the 4. 2 to the 4 is 2 times 2 is 4 times 2 is 8 times 2 is 16. So that's also 16. So 2, 4, 16, just like before. But now this is 2 to the 16. What's 2 to the 16? Not 256, but 64,000. Okay, you got to be exact here. 65,536. 65,536. You got the other pen. Okay, Anyways, they want a sequential. They want a recursive formula. It's very simple. G of 0 is equal to 2. G of n plus 1. It's not where you square it, but it's equal to 2 to the g of n. That's it. Okay, so that's the difference between this. Obviously, this grows faster than this. This is part B. Great, next. Number 7. 7, we get into languages. And we're going to do what we're going to do it. You ready? This is number 7. Sigma is equal to A, B, C. You get a bunch of words. And Sn denotes the number of words of length n that do not contain the string AA. Okay, so the first thing they say is calculate. So, S0 is equal to the number of strings. And we're going to count all the words of number of 0. I think this is the way they wrote an empty word. So that's a word. There's one guy there. Next, S1 is equal to the words of length 1 that don't have an AA. Well, A, B, C. That's equal to 3. Next, S2. Okay. S2 is those words in A, B, and C that don't have AA. So let's write down all the words in A, B, and C of length 2. Well, AA, AB, AC, BA, BB, BC, CA, CB, CC. Okay? Doesn't have an AA. Let's read that carefully. That do not contain the string AA. We don't want that one. Okay? And this is very simple because what do we have? We have words of length 2. Well, there are 3 times 3, 9 words of length 2, minus 1 of them is 8. Good. Let's do S3 because we're going to need it. The book doesn't say to do it, but we're going to need it. It says to calculate it, but we're going to need it. Okay, I don't want to write all 27 letters. Okay, let's think of it another way. You know what? So this is really equal to the number of elements in sigma 0. And this is equal to the number of elements in sigma 1. And this is equal to the number of elements in sigma 3, but not with that. So I want to write this another way. I want to write sigma 2 as sigma, better thought. I want to show you how I can make S3. Okay? S3 is basically all these words but with letters in front of them. So you can think of sigma 3 as sigma times sigma squared. So these are words of length 2, and now I want to add a new letter in them. Okay, so let's go through what letters I can add here. So I can, this word is not in the language because it has an AA. But what I can do here is I can put a B here. So I can put a B here, I put a B here, I put a B here, I put a B here. This gives me BBB, this gives me BBC, this gives me BCC, BCC. Okay, what else can I do? Okay, well, I can also put a C here. So I get CAB, CAC, CBA, CBB, CBC, CCC, CCA, CCB, CCC. Okay, great. Now, what about words that start with A? What about words that start with A? I want a three-letter word that starts with A. Okay, let's think about it. Okay, so I have an A. Now, I can't put an A again because that would be an AA. Okay, so I can put a B. Okay, I can, again, the word starts with an A. The next letter has to be an a B, or the next letter has to be a C. Okay, great. Now, what's over here? Well, that is a continuation of a previous letter. Well, what we're looking for words of length 3. If you're going to start with AB, the only thing left is these words. So it could be an A, it could be an ABB, it could be an ABC, it could be an ACA, it can be an ACB, it can be an ACC. Okay. So, let's go through it. The answer is as follows. S of 3 is equal to, you ready? 2 times, whatever the size of S of 2 is, it's 2 times it. Why? Because the letter B can fit there, and the letter C can be, the letter B can be the first letter of the next thing, and the letter C can be the thing. So I can take whatever words of length 2 that I have, and I take 2 of those, 2 copies of those, so that's 2 of S2. Okay, hold on. What else can I do? Well, I can take words of length 1 and add on to it either AB or AC. So that's plus 2 times S1. Okay? Okay, in this case this would be S3 would equal to 2 times 8 is 16 plus 2 times 3 is 6, which is equal to 22. So instead of 29, all of them, we have 22. Okay. Notice none of these have an AA. Great. Let's go on and do more. Okay. What about S4? Well, S4 is going to be a lot of 4-letter words. Those 4-letter words are either going to start with a B, so they're going to start with a B, and then words from S3, or C and words from S3, or AB and words from S2, those are words from S2, or AC and words from S2. Okay? So what we get is S4 is equal to 2 times S3 plus 2 times S2. Okay, so in this case it's going to be 44 plus 16. 44 plus 16 is 60. Okay, great. In general, let's erase. In general, Sn is equal to, well, a word of Sn minus 1 that begins with a B, or a word of Sn minus 1, I'm sorry, we should do this plus 1. Sn plus 1 is equal to a word in SN that starts with a B, or a word in SN that starts with a C, or a word in SN minus 1 that starts with an AB or an AC. Can't start with an AA because AA is not allowed. So what we get is Sn plus 1 equals 2 times S of n plus 2 times S of n minus 1. Okay. Okay. Great. Let's do number 9. We're finished. Number 9. Number 9. Oh, that's tough. Sigma is equal to AB. Tn is equal to number of words of length. Yeah, I'm sorry, I missed that up. LENGTH. N with an even number of A's. Okay, so calculate T0, T1, T2, and T3. Let's do it. T0 is equal to the number of words in S and whatever. So this has an even number of A's. It has 0 A's, so that's an even number. So that's equal to 1. That's an even number of A's. Okay. T1 is equal to words of length 1 that have an even number of A's. So just B. That's the only word that has an even number of 1, because if you put in an A, that would have 1 A, and that would be illegal. So that's 1. T2. Let's look at words of length 2. Let's write them all out. AA, AB, BA, BB. Okay. This has an odd number of A's. This has an odd number of A's. This has an even number of A's. This has an even number of A's. So that's equal to 2. Let's do T3. Let's write them all out. AAA. It's going to be a pain in the neck, but fine, let's do it. Let's do it. We'll do it like logic. AAB, ABA, ABB, BAA, BAB, BBA, BBB. Okay, that's 8 words altogether. Okay. This has an even number of A's. This has an odd number of A's. This has an odd number of A's. This has an even number of A's. This is an odd number of A's. This is an even number of A's, an even number of A's, an odd number. So 1, 2, 3, 4. So this is equal to 4. Okay. So now we have to think of a way of doing it like we did before. T3. Okay, maybe this doesn't work, but okay. Okay, I think I have a way of doing it. It's as follows. How many words are there? These are 2. There are 2 letters in the alphabet. How many words are there in length n? So sigma to the n. Those are words of length n. How many are there? Well, there are 2 to the n. Right? Because each one of the letters can be A or B. So there's 2 to the n of them. Okay? Great. Now, let's say I wanted to make T of n. Okay? I want to make T of n. I want to figure out what T of n is. So, look what I do. Well, take all the words that are not, take all the words that have an odd number of A's. 1, 2, 3, 4. Okay? Take all the, so there's 4 of them. Well, okay, fine. So half of them are going to have odd and half of them are going to have even. Well, if you look at all T of n of them, half of them will be odd and half of them will be even. So I think 2 times n minus 1 and put an A in front of them. So these are the ones that have odd. If you put an A in front of them, they'll now have even. So that's good. Plus, take the ones that are even, that's 2 of n minus 1, those are even, and put a B in front of those. So let's write it like this. A times a word with odd plus B times a word with even A's. Odd A's and even A's. Okay? Anyways, so this is equal to, but that doesn't work. It's equal to 2 to the n. That's not true. Okay, anyways, I'll have to do this one in class. It's a little bit hard. Have a wonderful day. That's the end. I'm too tired to do this. Bye.